Basic calculus differentiation methods: product rule, quotient rule, and chain rule. The first problem involves a function using the product rule for differentiation. This includes one quantity multiplied times another quantity. So the product rule format is f prime g plus g prime f. So in the given function, the f component is the first quantity or the quantity on the left, and the g component is the second quantity or the quantity on the right. So therefore we make a list to designate what f and g represent with respect to the function. So f is equal to 6x to the fourth power, and g is equal to 8x to the negative third power. We then find their derivatives, f prime and g prime, 24x cubed and negative 24x to the negative fourth respectively. Then we apply the product rule format, f prime g plus g prime f, and when we simplify this expression, we evaluate a derivative that is a linear slope. Next, we move on to an example solving a function using the quotient rule, and the quotient rule is defined as f prime g minus g prime f divided into g squared. So in the given fractional expression function given, the numerator is the f component and the denominator is the g component as an entire quantity. So therefore we designate what represents f in the given expression, 3x squared plus 1, and g represents x plus 5. Then we find their derivatives, 6x and 1 for f prime and g prime respectively. Then we apply the quotient rule format, f prime g minus g prime f divided into g squared, the quantity of the denominator squared, and when we simplify, we calculate the following derivative for the given function. And lastly, we use the chain rule when dealing with a quantity expression function for which the entire quantity also is raised to some power or taken to some exponential value, negative or positive. So the chain rule specifies that the entire quantity listed in parentheses will represent u, and then we apply the normal power rule for differentiation. We take one out of the, reduce the exponential value by 1 and place the original exponential value as the coefficient times the quantity without doing anything to the quantity. Then we multiply that derivation times the derivative of what's in the parentheses. So you can see here that after we do so, we multiply the given quantity u times its derivative u prime. So here we start with reducing the exponential value and converting it into a coefficient times the quantity expression, and then reduce to 1 less power to the 7th power times the derivative of the quantity, so 15x to the 4th plus 2. So when we simplify, we can rearrange either in ascending or descending order on each quantity expression because it's distributive or multiplied across. The result will be the same, so it's acceptable to put the second quantity first in parentheses, or the second quantity first or the first quantity second, but for clarity's sakes, usually they are put in ascending order in terms of exponential quantity function. So 8 times the quantity of 15x to the 4th plus 2 times the quantity of 3x to the 5th plus 2x minus 3 to the 7th power is the correct answer. So the chain rule specifies that you start with the outside exponential power in differentiation mode first, taken down into a coefficient and then reduced by 1 power, followed by multiplying the given quantity expression without disturbing it times its derivative. Thank you for watching this video and have a great day.